Hello, my name is Ginger Grant. I am a Microsoft MVP and a Microsoft virtual trainer. I also had the opportunity to attend SQLDay in 2019 before everything shut down, and I really enjoyed the experience and hope to attend in person again at some point in time. Today, I'm going to be talking about Azure Databricks and Azure Synapse Analytics. These two products are often talked about together because they are both provide similar functionality in that they are both Spark processing engines. So I'm going to talk about the differences between the two, and what I hope to do is provide you a reason to use one over the other so that you can determine which one is best for you and your environment. So today we're going to be reviewing the similarities, diving into the differences, and looking at not just, hey, which one should I use? As a matter of fact, Microsoft is actively supporting both of them, and they are looking to enhance both of them. As a matter of fact, there's some new features that were recently added to Databricks, so you don't need to worry about Microsoft discontinuing support. So that's not an issue. So let me go ahead and let's start talking about what the two of them do. So Azure Synapse and Azure Databricks, they're both designed to be cloud-based scalable solutions for analyzing and processing the data using scalable Apache Spark clusters. Spark combines a file structure with compute engine and a set of libraries designed to process the data efficiently by dividing up the task and processing the tasks concurrently. Now, one of the ways that this is possible is the compute engine is separate from the data. And this means that if your process is running slowly, you can change the underlying compute resources to match your compute tasks. If you're doing some machine learning for the CEO and he doesn't want to wait, you can use all the cores and CUDAs available to process the data in minutes. If you have a nightly task that has a 4-hour window, you might select a more economical compute and change it if the data changes over time. The processes or pipelines are designed to run as workflows, and these are going to process the data as you need it. Want to run a nightly job? No problem. Both Synapse and Databricks will load up a Spark compute pool process, the workflow, and then turn the pool off when the process is done. Spark pools turn themselves off, so you don't have to worry about running up a huge bill because you forgot to turn something off. Spark was created in large part to perform machine learning tasks, as they often vary quite a bit in the amount of compute needed. Sometimes you're going to need a ton of compute power to perform deep learning analysis, and Spark performs really well in that environment. So Spark was written to support multiple languages so that you can create code in multiple languages, and most often that's going to be Scala or Python, but others are supported, and we'll go into the specifics on that in a little bit. The creators of Spark know that people also want to use SQL to analyze their data, as that's commonly supported as well. As a matter of fact, they estimate that 90% of the library calls are for processing SQL. So, of course, they have a shared speaker set. They both use Delta Lake. Delta Lake is something that is incorporated into the Spark engine, and it allows you to do something that they call time travel. The rest of us would call backups, because you can use your data based on a point in time view of the data. It automatically does backups. They both use the Anaconda feature set. This is part of Python, and they both have those libraries loaded. They both have Azure Active Directory integration, so both of them are going to be fully integrated into your Azure environment, even though Databricks is a product that Microsoft purchases and is not owned by them. It's owned by the Databricks company, and they handle the updates to that product, but it's fully integrated into Azure. They both have machine learning support, and you can incorporate Azure ML into your environments with both of them. You can use them for either batch or streaming, and they both have source control integration with DevOps and GitHub. As a matter of fact, this was one of the last things that was added before Synapse went GA, because everybody knows that you have to have DevOps and or you need to have source control in order to be able to release the product. So Azure Synapse was introduced in November of 2019. It was introduced at Ignite, and I heard about it at PASS in that year. And when it was first talked about, what they talked about was the fact that Azure Synapse was the replacement for Azure DW. So it was the new Azure DW. Well, that changed in March of 2020 when they were talking, when all the other features were really added. So that the features that were added, of course, being the Spark and compute and the other elements in the environment, including integration and the built-in pools. So it's built upon Azure Data Lake Gen 2. So with Synapse, you actually need to have a Azure Data Lake Gen 2 to be able to even create the environment. They're very strongly integrated. But that's primarily due to the reliance of the built-in pool, also, which is now called the serverless pool, which uses Azure Data Lake Gen 2. And Synapse is a product that allows you to process data in multiple ways, of course. You can do Spark with it, but you can also use it for integration using components that were literally taken from Azure Data Factory, as it includes the code base included in it. So if you want to build ADF style pipelines, they call it integrate. It's the same code, with the exception that you can't do the full SSIS integration into it. And you can also do serverless queries on your data and create virtual databases. So those are the three different ways that Synapse provides for processing your data. So for Databricks, that was added to Azure in March of 2018. It was added to AWS, I think 2 years before that. It is not a Microsoft product, as I said earlier. This means that if you have used Databricks within any environment, that you can use it within Azure. And it was developed by the creators of Spark as a Spark improvement. It's kind of one of those things, though many of you may have had in areas where, you know, you get done with something and you say, shoot, this would be so much better if I could just redo it. Well, that is what 80% of the people who created Spark decided to do. They decided to create a version out of the open source environment so that they could be paid. And they determined what they could do to make the engine go faster. So it includes all the improvements that they thought of, and the biggest improvement over Spark is that it is purely a cloud-based environment. So you have to have the cloud to be able to run it, and this provides the scalability that's needed to ensure that you can use as much compute as you possibly need. So, it is a managed team environment too, because they knew that what people wanted to do is work together in teams, and they needed to make sure that their product really supported that. And of course, they included source control. So that is the origin of what Azure Databricks does, and it can provide a lot of really great Spark pipeline functionality as well. So of course, there are feature differences between the two of them. The two of them are not the same. And what the difference is between the two, well, they are both running Spark, but you'll notice that they're not the same version of Spark. So with Synapse, which is the one on the left, Synapse is running Spark 2.4, and Spark 2.4 is the earlier version, unfortunately. I know that it is on the roadmap to get to Spark 3.0, but there's been a whole bunch of interesting updates that have happened into the Spark engine, and now it's at Spark actually 3.1. And this has kept it from moving to Spark 3.0, which is used in Databricks. Now, they both use their own compute, since compute is separate, but in Databricks they call those clusters, and in Spark they call them pools. In Spark, because it runs in Synapse, it's running TSQL, whereas in Databricks it runs ANSI SQL. They both support Scala and Python, but in Synapse they also support .NET, which is not supported in Databricks, but it is. But Databricks does support R, and R support is not available within Synapse. So, one of them, they're of course older than each other. I mean, Synapse was been added on December 4th of 2020, and Spark, that's when it went GA. And in Databricks, it's been in Azure since 2018, so it's got a little bit of a difference there between the two of them. So let me go ahead and open up both of them so that we can take a look at the differences here between the two. So let's take a look at my Synapse environment first. And one of the things that both of them have in common is they both open you up into a development environment. So the environment that you are logging into, of course, is using your Azure Active Directory security based on your tenant, and uses the information that you have provided, using RBAC to build elements that you might be interested in. So the difference, of course, being that if we look at what they both do, if I'm looking at my Spark, I'm looking at notebooks. So I've got a bunch of notebooks here, for creating machine learning, doing full-on integration with that. It's a little bit different environment as far as the notebooks version. It's using a different notebook than it's using in Databricks, which isn't that obvious. So from I'm just looking at Spark perspective, it's pretty much the same. I can look at my different Spark clusters here. So they are my Apache Spark pools. The pools that exist are the ones that you create. There are some differences in the pools, which we'll go into in a little bit. They both take about 4 minutes to load, so that once you start it up, it does take a little bit of time. But you'll notice that there's a whole bunch of other things that are integrated that are not in Databricks. I've got things like integrate using so I can create pipelines here. And I can, although there isn't a direct way to convert them from Azure Data Factory, they do exist. I also have the ability to look at my data and create the ability to query directly using the properties within Azure Synapse. I can browse my data pretty easily and then take a look at the data by just doing some, right-clicking on it and selecting top 100 rows. Oh, by the way, since they're both running Spark, they both prefer of the Parquet format is a file format that will operate most quickly on it. So here you can see my data. Now, not that you can't do this within Spark, of course. When I'm doing that, I would do it using Spark SQL. So you've got some different options. So let's take a look at Databricks as well. Taking a look at that environment here. And here's the integration environment that I was talking about that you couldn't see. All right. So let's take a look then at Databricks. You see here that it's a similar environment. Well, maybe you didn't see it before. So if you are in the Azure environment, you're going to need to launch your workspace. and your workspace will be where you are going into. Now it's going to use the account that I have associated with my Azure tenant, which is of course the top one. I've got a number of different accounts and it needs to know which one to use. And it's using Azure Active Directory single sign-in. So we have a similar sort of environment, and we've got a home. We've got some places for documentation. My workspace is the area where I've got my different environments. I have user information. I could, of course, have multiple users in my workspace here so that I have multiple places to take a look at or share different elements that I have. I can create shared environments or notebooks. I can also take a look at some of my recent notebooks. Notice the environment here a little bit different than in Databricks, but it's pretty similar in form or fashion. So I've got data that I can connect to so that I can access the data elements within Azure or other places that I wish to connect as well. I can create jobs. My jobs will be running my data all of the time, and I have different kinds of clusters that I can create that have different elements that allow me to run my different jobs. Now, one thing that's kind of interesting about Databricks is that the clusters automatically go away if you haven't used them very frequently, which is no big deal, again, because your compute is separate from your code, so you can always create another cluster. They are Spark clusters, so that the clusters will take, again, about 4 minutes to start up. All right, so the differences between the two of them, which you might have seen in my very abbreviated demo since my screen froze, is that while Spark does what it does very well, it is a bit more limited in the different feature sets that it provides. So Azure Synapse is a little bit more than what they like to call at Microsoft, which is yet another Spark interface. Yes, it does Spark, and you can use it to create Spark processes. But many people use it and never touch Spark, because instead, what they're using is the different elements of Synapse. So they're using the integrate portion, the ADF portion, to do pipelines, and they are perhaps creating Azure data warehouses using the other features, using the dedicated SQL pools contained within Synapse. So you may be using Synapse and never touch the Spark elements at all. Of course, it integrates with other Azure services. A couple of things that it integrates with Synapse that don't, right now anyway, integrate with Databricks are Purview, which is a new Microsoft feature that allows you to document your data elements, and it's got a tighter integration with Azure Machine Learning, allowing you to call some of the Azure Machine Learning component elements from within Spark. And it's got some no-code features that you can integrate using that environment as well. So the idea with Synapse is it's an encompassing environment. So it's got the data warehouse, it's got serverless pools, and it's got Spark notebooks. It also integrates with Power BI, Cosmos DB, and very soon, it's on the roadmap, it's going to be integrating directly with Azure SQLDB. So it's a lot more than just looking at a Spark environment. It's designed to do quite a bit more. It's not designed just to be a Spark replacement. It's really designed to be the environment where you house all of your data so that you can process all of it. So looking at kind of a different scope and feature set than Databricks does. So it's got some only in Synapse elements. So it's its integration with Azure linked services. This provides the ability to really directly connect to different elements without a whole lot of work. You just have to click on your linked services and you can connect to it. It's a little bit more complicated, takes some code in to do the same type of functionality within Azure. So within data warehousing, then it has, of course, that's not available in Synapse. It allows you to do TSQL queries from flat files, integrate Cosmos DB, and create virtual databases that you can use in any kind of environment. So it's got a different scope that's available within it. So it also has the integration component. So that's one thing that it only has. So it shares the same code base as Azure Data Factory, runs a Spark source integration runtime. The integration runtime is also in Spark, which means that it does take a little bit to spin up. And you can incorporate notebooks and persisted tables within Synapse. So another thing that's only in Synapse, is not part of Databricks, is a data warehouse. So this provides high-performing access to big data. If you have over a terabyte of data, this is where you are going to want to store it. You can use compute in that environment in a different way. You can scale it up and down to meet your needs. And it's got standard data warehousing tasks, and it also has the ability to change the pools as you need them. So if you have high intensity jobs, then you can use a larger pool. And this is separate from Spark. This, of course, is for data warehousing. It also contains some really neat features when it comes to allocating resources, so that your resources can be allocated to specific users, so that if you want your CEO's stuff to run faster, you can make that happen within Synapse. So it also supports TSQL, not SQLite or ANSI SQL. So this allows you to create persisted SQL queries, use TSQL to do exploratory analysis instead of Spark SQL. While you can do it with both of them, it just depends on your environment, which one you want to do. Databases can be created which are logical on top of flat files, and those databases can be persisted so that you can access them within Management Studio. So and it'll also allow you to connect to other databases and Azure Link Services, again, like Cosmos DB, allowing you to integrate them fully within your Synapse environment. So the other thing that you have that's available in Synapse is a full Azure ML integration. Got that wrong. That's the wrong data there. And that provides a no-code option. Also cognitive services, allowing you to integrate sentiment analysis and anomaly detection into your code. The way that this has happened is actually Microsoft has added to the Spark environment, and using they added a open source component which provides for better integration to cognitive services so that you can call it more readily. So also in Synapse, you also have Power BI integration, which this allows you to do exploratory analysis within Synapse. And you can incorporate a Power BI workspace for reporting, and then you can create views for a virtual data warehouse as well. So you've got the full-on capability of Power BI from within Synapse as well. So only in Databricks. So what's the difference? What does Databricks have that Synapse doesn't? So it's using a proprietary version of Spark. This is actually kind of interesting because actually there is more of an open source commitment when it comes to data, when it comes to Microsoft, which is kind of an interesting position for it to be in. That Microsoft has the open source version and Databricks has a proprietary version. But the reason that this occurs is that the proprietary version was designed to go faster. So the Databricks team has added some feature functionality to it, which allows the Spark to perform more optimally. It has different kinds of integrations with other products that you can connect to. It has it's worked with several different vendors, allowing you to incorporate them directly into the Databricks environment. And then it's got different compute resources. The compute resources that it has that are not available within Spark are the ability to use GPUs. Now, GPUs are the graphical components which were added to basically allowing you to use the compute that exists in video cards. So you have the ability to use more memory by allocating the GPU resources in addition to standard memory, so allows for greater compute capability. And that is not supported in Synapse, but is supported in Databricks, meaning that you can allocate compute which will go faster because of the type of compute that is available to it. So it uses proprietary version of Spark. It is also using a later version of Spark. And this means it has some performance enhancements over open source Spark as it's using the latest version, but also with enhancements. So the version that it's fully compatible with the Spark engine, but they add more features and functionality to it, making it go up to 30% faster because of the way that they are doing, the way that they have written it to perform. So it's done to improve the performance. So it also integrates with other language using interfaces using Databricks Connect. This provides like partner integrated model management. It's also easier to share your notebooks within Databricks because the environment has different administration capabilities that allow you to better share the environment. And that means that two people can work on notebooks, and it's relatively easy to do. It also has integrated the Delta Lake differently. The way that it's integrated Delta Lake, it's kind of more encompassing because it allows you to use it within the environment. Now with it just because within Synapse, it doesn't have the Delta Lake integrated, say, in anything but the Spark environment. So it's a little bit better integrated than it is within Synapse. So only in Databricks do you have this GPU compute. This will provide the additional overall capacity, so you can make much larger resource calls with Databricks, meaning that harness much larger compute. Of course, you're going to be paying for that, and these graphical processing units, add additional power, providing you with the ability to run a lot faster. All right, let's take a look at the two environments, and this time make sure that you can see them. All right, so diving into some integration elements within Synapse, and then I'm going to be taking a look at some additional elements within Databricks. So a couple of things that are kind of interesting that I wanted to highlight here is the AutoML integration. Now I can, using the integration that's available within Synapse provides me the ability to literally, and I'm going to show you, don't want to get too far in the weeds here on my example, but I wanted to show you here that I have the ability to import my workspace in Azure ML. And what this is allowing me to do is use my Azure ML environment and take advantage of some of the functionality that it provides. One of the things that it provides is the ability to create is using the Azure ML core element to select algorithms for me. So if I'm looking for doing machine learning, what I'm doing with this particular code is I'm basically saying, hey, I've got a regression experiment here. I'd like to set some parameters for how long it takes to time out, set what I want my primary metric to be. Here's my R2 score. And with that, please go run through all the algorithms that you have and find me the best solution based on machine learning. So use machine learning to create an algorithm for machine learning. So I can make those calls using the compute that's available in AutoML to do that. Kind of a unique feature within the Spark environment that I have with me. Now, taking a look here within Spark, taking a look at the languages here, you'll notice that I've got PySpark, which is what I'm primarily using in this notebook. I've got Scala, .NET, and Spark SQL. So looking at my other components, the way that it works, I can, of course, use this to create jobs, but most likely if I'm going to be creating a job, what I'm going to be doing is creating it here with integrate because this allows me to call notebooks as part of my environment, and it better incorporates with other things that I've got going on. I've got management elements in here, taking a look at the way that my different components are running. And again, here I've got my external connections, providing me the ability to create link services. These are my existing link services that I've got created, allowing me to have ready access to a number of different storage elements, and I'm adding Cosmos DB and Key Vault very easily to my environment. So I've incorporated a number of different elements within my environment using link services. And of course, I've got integration to Purview so that I can make sure that I have better and analyzed and documented all of my data. So, and I can take a look at my different pipeline runs, etc. So let's take a look at Databricks and look at the things that it provides as well. So one of the things that it provides, of course, is the ability to create jobs within Databricks, so I don't have to engage in Data Factory if I don't need to, if I don't wish to, and I can create jobs based on whatever I want to, looking at calling my notebook, creating clusters that spin up, providing alerts for me, doing whatever kinds of things that you would expect a job to do. It's kind of like a superset of running jobs within Azure, within a SQL database environment, if you are familiar with that. Now, when it comes to clusters, what I was talking about within this element is looking at, and we'll just create one here. What you have is you've got different elements that you can create using your compute elements here. So notice that I have DBUs, and I also have, if I click on that, I have GPUs as well. So I've got additional GPU elements. Now, naturally, these are the more expensive elements that you could possibly create. You've got a number of different cores, but you can also add the GPU elements as well. Now, one of the things that is different about the way that it works is it has, the model management is through the Spark model management, whereas Synapse is incorporating Azure ML. It's using model management here to be able to do that. It also has different administration, which is one of the things that it provides that's really nice, is this area here where I've got a number of different users, shared elements, which means that I can have everybody accessing the notebooks that I have within my environment, which is not something that's really able to do within the same way within Databricks. Now, other thing that I wanted to mention is that the code that you use within the two environments is not exactly the same, especially when it comes to Delta Lake. So if you do decide to switch from one environment to the other, you can't just cut and paste your code. There's going to be some changes that you're going to need to make sure that the code is working in the different environments. So so with that, so which one is the best fit? What are you looking to do? What are you trying to do within your environment? Are you trying to integrate pipelines using Azure Data Factory? Although they call it integrate in Synapse, it is the same code. So this depends greatly on the skill set of your users. Now, I know in a lot of environments, a lot of the ETL is now being done using using Spark entirely, so that people are writing that and they're not using ADF. But what's your environment like? How skilled are your users? What do your users provide? Data warehousing. Do you want it? Do you need it? If you're looking to do that, obviously that's something that you would want to have within Azure Synapse. Are you looking to leverage, this goes also back to skills, because a lot of the choices for which ones you would select has everything to do with the different skills of your users. So if you are looking to do that, then you are looking to incorporate, things that people find helpful. So, what are your users what are your skill sets of your users? If you want to write .NET, then you're going to be doing Synapse. But again, you will need to learn Spark, because that is important for those environments. Open source support. This is actually really kind of funny to me, but if you are a big open source company, you're probably going to better like the Synapse environment, because it's using open source versus proprietary technology, which is kind of interesting when it comes to Spark. So one of the things that Databricks does, I don't really have a demo for this, but Azure Databricks provides a better Spark streaming environment using integration with Kafka. If you are doing streaming and looking at the two different products, you'll probably find that streaming works out better from within Databricks. Databricks does have the latest Spark features. They're much faster at incorporating the two elements. There are a number of kind of neat features that were added as part of Spark 3.0 that are not in Synapse, including full-on ANSI SQL within Spark SQL, as well as the ability, some of the additional features and functionalities which were added to Spark that are not included in Synapse, but they're only in Databricks. It also includes R. So if you have a lot of code in your environment where you are running R, then the better fit would be Databricks, because they have R support and Synapse doesn't. Now, I understand that it's on the roadmap, but hey, it's not there now. So if you are trying to utilize a lot of your R code, then you're going to want to use Databricks. Now, I will say that in order to use the scaling functionality of either of them, you will have to make sure that you are using Spark R, not just standard R, so that you will have the ability to use the clusters. As a matter of fact, a friend of mine was working in an environment where they had just migrated all of their code and put it into Databricks, and they were surprised that it didn't go any faster. Well, the reason that didn't happen to go any faster is because that's not really how it works. You have to make sure that you're using Spark code. So that's what makes the whole cluster magic possible, is the fact that you're using Spark. And it is a proprietary version, but that does mean that it can go faster. If you are running very large jobs, chances are that with Databricks that they will perform more readily, so that you will have better speed performance if you're processing very large amounts of data, not be based on the way that Spark works, and this is outside of the different clusters using GPUs. But you can use both. I mean, what's best in your environment? You don't have to necessarily pick one from the other. You can incorporate them no matter what's going on. So you can call Databricks jobs from within Synapse. You can use Databricks for, targeted ML tasks, something that is very important, that it uses faster resource and processing power. You can then go back and use Synapse for data warehousing if that's what you need. There's no, you have to, fall into one or the other. Use the different elements that are better, or that are, frankly, one has it, the other does not, and incorporate the best of class in your environment. Create data lakehouses with serverless pools and use those. If those are really great, by the way, if you're looking to create Power BI marts, if you've got a whole lot of data lakes that you've got out there. So there's no reason that you have to use one or the other. You can definitely use both of them in your environment. You don't have to pick that one and not the other. So what's the best fit for your environment? Which one are they going to say, yes, this is the version that you want to use? Well, naturally, it depends. What kind of skill sets do you have in your environment? Do you have a lot of R code that you're trying to use? What kind of languages do you want to use? Do you want to write .NET and Spark? Integration. How do you choose to do integration in your environment? Are you choosing to write it all within Spark? Are you looking to Are you looking to have different languages? Are you looking to just do something in ADF kind of environment? Is that's how you like operating? Then you'll want to use Synapse. If you don't really care about that, you just want to get a whole bunch of Spark going pretty quickly, you may decide that in your environment that it works better if you use Databricks. For streaming, if you were doing full-on streaming, you're probably going to like the performance of Databricks, especially if you are not using event hubs and if you're using Kafka. So it depends on how you're choosing to stream, but if you're using a Kafka environment, I'm thinking that you're going to prefer the performance in Databricks. Not that you can't do streaming within Synapse, of course you can. But if you are looking at the feature functionality set, you're probably going to improve you're going to be happier with it in Databricks. If you're looking to analyze a large data lake that you've got going on, you're probably going to want to use Synapse for that, because honestly, it's a whole lot easier to query it than to do a point-and-click operation than write all of your code within Spark SQL. So it provides a different, better environment for you there. Spark performance. Do you need to run the fastest, hugest Spark ever? If you do, then you're going to want to use Databricks. That is going to be the better environment for you. But if that's not, and also the proprietary stuff does make a little bit of a difference. And then lastly, environment. How much sharing of notebooks do you really need to do? This is much easier to do in Databricks than it is in Synapse. Of course, you can both add people to the environment. It's just the way that they integrate is a little bit different. So if I was to say, hey, pick this one, I'd need to know these elements about your environment to say which one would be the best solution for you. So in summary, we took a look at the common elements of Azure Synapse Analytics and Azure Databricks. We looked at what the two different elements do, how that they use Spark. We detailed the feature differences, what each is designed to do. The environment that Synapse is designed to be a much larger environment. Spark is only a part of it. Spark is what Databricks does, and it does it very well, very efficiently. But that is the entirety of what it can do, where Synapse is designed to do more. We also looked at which is important in your environment. What different elements do you have going on in your environment that would direct you to pick one over the other? And with that, I was left some time so I could take some questions from the audience if you had any questions about the two different environments. So just curious, are people here, are you Databricks or Synapse users? Have you used either one of them? Are you looking to see which one you want to use in your environment? What's the experience that you guys presently have? Any thoughts about that? Curious if you are evaluating these or if you are looking at this because you've already got Databricks because do have a larger environment created because they have been around longer. Oh, you haven't decided yet. Okay, well that makes sense, Adrian, because hopefully you'll find this, helpful because, there is no like wrong answer. It's just basically what the different elements are in your environment. I'm glad and I hope you find this very helpful when you decide what you are choosing to do going forward, Adrian. Well, with that, I really wanted to thank you very much for attending today. I know this is a really great conference and it's kind of different with this different avatar environment. And so sorry for the technical difficulties and I hope you have a great rest of the conference.